Jupiter has 101 known moons, yet the strangest part is not how many we can see. It is how many may still be hiding in the darkness around the giant planet. NASA and other astronomers are finding that Jupiter's moon system is far more crowded, broken, and mysterious than it first appeared. Some of these objects are so tiny and faint that they can vanish into the background of space, almost as if Jupiter is keeping them hidden. And the latest discoveries are forcing scientists to ask a simple question: how many moons are actually still missing? If stories like this are why you look up at the night sky, stay with us and subscribe. More strange discoveries are waiting beyond the planets we think we already understand. More than 400 years ago, Jupiter changed the way humans saw the solar system. In January 1610, Galileo Galilei pointed a small telescope toward the giant planet. At first, he saw what looked like several tiny stars beside Jupiter, but when he watched them night after night, something strange happened. The points of light moved around Jupiter. They were not stars at all. They were moons. Galileo eventually identified 4 large worlds: Io, Europa, Ganymede, and Callisto. Today, we call them the Galilean moons, NASA 1. For a long time, these 4 moons seem to be the main story. They are enormous compared with most of Jupiter's other moons. Ganymede is even larger than the planet Mercury. Callisto has a heavily damaged surface covered with old impact marks. Europa has a thick shell of ice hiding a huge ocean. Io is covered with volcanoes and is the most volcanically active world known in the solar system. But Jupiter was never simply a planet with 4 moons. The deeper scientists looked, the stranger the system became. In 1892, astronomer Edward Emerson Barnard found another moon, Amalthea. It was much smaller than the 4 moons Galileo had seen. Then more distant moons began appearing. Some were found in the early 1900s. Others were discovered many decades later. These outer moons were different. They were tiny, dark, and often traveled on strange paths around Jupiter. Some moved in the opposite direction from Jupiter's rotation. Some traveled extremely far from the planet. Many looked more like captured space rocks than worlds that formed beside Jupiter. That detail matters because Jupiter is not just large, it is enormous. Its gravity reaches far into space. Anything that passes close enough can feel a powerful pull. A small asteroid can be captured. A larger object can be pushed into a new path. Over billions of years, this creates a giant cosmic neighborhood filled with objects moving in different directions. What looks like one moon system is really a huge collection of worlds, broken rocks, captured objects, and debris. And this is where the idea of Jupiter's missing moons becomes interesting. When scientists say a moon is missing, they do not mean NASA knows that a specific moon exists and has somehow disappeared. They mean there may be many very small moons that have not yet been detected. The moons are not necessarily being created right now. They may have been orbiting Jupiter for billions of years without anyone seeing them. The reason is simple. Distance and size can hide almost anything. A moon only a few kilometers across can be incredibly faint. At Jupiter's distance, sunlight reaching such an object is weak. The moon reflects only a tiny amount of that light back toward Earth. By the time the light reaches a telescope, the object may look like a tiny moving dot buried among thousands of stars. And Jupiter makes the search even harder. The planet itself is incredibly bright. Its glare can hide small objects close to it. Imagine trying to spot a grain of dust beside a stadium floodlight from many kilometers away. That is not exactly what astronomers face, but the basic problem is similar. The smaller the moon, the farther it is from Jupiter, and the closer it appears to the planet in the sky, the harder it becomes to find. And this is why the number of Jupiter's moons has changed so many times. Scientists did not suddenly make new moons appear. Better cameras and longer searches allowed them to see objects that were already there. In March 2026, the International Astronomical Union's Minor Planet Center confirmed 4 additional Jupiter satellites, bringing the official total to 101. IU-2. NASA now lists 101 officially recognized moons as of March 2026, while also warning that the number does not show the full complexity of Jupiter's system. NASA Science 3. That number 101 sounds huge, but here's the part that can be easy to miss. The official count is not a complete inventory of every object circling Jupiter. Scientists know there are thousands of small objects in the giant planet's neighborhood, and not every tiny object has been confirmed as a moon. Some may be too small, others may have orbits that are difficult to track, some may appear in only a few images before disappearing from view. So the real mystery is not whether Jupiter has more than 101 objects around it. It almost certainly does. The mystery is how many of those objects are true moons, how they formed, and how many tiny ones are still waiting to be found. At first, scientists expected Jupiter's outer moons to tell a fairly simple story. The planet formed billions of years ago, and some smaller bodies were captured by its powerful gravity. Then collisions broke larger bodies apart, creating families of smaller moons. That basic picture still works surprisingly well, but every new discovery adds another piece to the puzzle. Consider the outer moons. Many are tiny compared with Ganymede or Callisto. Some are only a few kilometers wide. That means a single one could be smaller than many cities, yet it can still orbit Jupiter for billions of years. It does not need to be a giant world to be a moon. It only needs to be held by Jupiter's gravity and follow a stable orbit. Scientists have found groups of these distant moons that seem related. The moons in some groups travel along similar paths. That suggests they may be fragments of a much larger body that was destroyed in a collision long ago. In other words, Jupiter's moon system may contain the remains of ancient cosmic crashes. A moon that looks like a single small rock today could actually be one piece of a much larger world that no longer exists. Now, the story takes a strange turn. Scientists once expected the smallest moons to be the hardest part of the system to understand, but the more they find, the more the small moons reveal about Jupiter's violent past. They are not just extra dots on a list, they are clues. Think of a broken glass on the floor. If you only see one piece, you cannot know exactly what the original glass looked like. But if you find dozens of pieces, their shapes and positions can tell you something about what happened. Jupiter's small moons work in a similar way. Their orbits can act like pieces of evidence from ancient collisions. So when a new tiny moon is found, scientists do not simply ask, how big is it? They ask, where does it travel? They ask whether it moves with other moons. They ask whether it travels forward or backward. They ask how far it is from Jupiter. And they ask whether its orbit suggests it was once part of a larger body. One of the most interesting clues is direction. Most of the large planets and major moons in the solar system formed from a disk of material that was moving in an organized direction, but some of Jupiter's outer moons travel backward compared with the planet's rotation. These are called retrograde moons. The word sounds complicated, but the idea is simple. They move around Jupiter in the opposite direction from the planet's spin. That strange motion is a clue that many of these moons may have been captured. They may not have formed where they are now. Instead, Jupiter may have grabbed them from the wider solar system. Some could have started as asteroids or other small bodies wandering through space. This also explains why scientists think Jupiter's outer moon system may be much larger than the official list. If Jupiter captured objects over billions of years, there is no reason to assume that every tiny captured object is still easy to see. Some could be extremely small, some could be dark, some could be buried in crowded regions of the sky. And now comes one of the most important facts. In 2018, astronomers announced 12 new Jupiter moons, including objects only about 1 to 3 kilometers wide under their estimated dark surface assumptions. That means some of Jupiter's moons are only around the length of a large airport runway or less. You were to imagine trying to find something that small while it is millions of kilometers away, moving through a giant field of stars. Would you have guessed that objects this tiny could remain hidden around the largest planet in our solar system for so long? If that surprises you, leave a like and tell us in the comments whether you think Jupiter still has dozens more moons waiting to be confirmed. The technology used to find these moons is part of the reason the count keeps changing. Modern telescopes can take extremely sensitive pictures of huge areas of sky. Astronomers take several pictures of the same region at different times. Stars remain almost fixed compared with the distant background, but a moon orbiting Jupiter moves. That movement becomes the clue. The computer can compare the images and search for tiny points that shift position. But even then, finding a moving dot is not enough. The object must be observed again. Astronomers need enough measurements to calculate its path. Only after its orbit is understood can scientists be confident that the object is actually a moon and not a distant asteroid or some other object passing through the same area. This is why discovery announcements can take time. A tiny dot might appear in one image, then it might vanish. Astronomers must search for it again. They may have to wait for the object to return to a useful position in the sky. Only repeated observations can turn a possible moon into a confirmed moon. The process sounds slow, but it is revealing something important. Jupiter is not surrounded by a neat collection of large, round worlds. It is surrounded by a huge and messy system. Some moons are giant, some are tiny, some may be fragments, some may be captured objects, and some may be so faint that we have not even noticed them yet. NASA's own description of Jupiter's moons points to this complexity. The agency notes that many of the smaller moons orbit much farther out than the Galilean satellites. It also says larger distant moons may be captured asteroids, while smaller ones are likely fragments produced by massive collisions. NASA Science 5. That means the moon count is really a window into Jupiter's history, but there is another side to the story. The newest NASA discoveries are not only about finding new names and numbers. Spacecraft are getting close enough to study moons we already know, and what they are finding on those moons can be just as surprising. NASA's Juno spacecraft is a perfect example. Juno has been orbiting Jupiter since 2016, studying the giant planet and its powerful magnetic environment. During its mission, Juno has repeatedly passed close to Jupiter's major moons. Each close pass gives scientists a different look at worlds that were once only tiny points in a telescope. In May 2026, Juno captured a close view of Thebe, one of Jupiter's smaller inner moons. The spacecraft passed about 3,100 miles or 5,000 kilometers from Thebe. Its navigation camera captured the moon at a resolution of about 1.9 miles or 3 kilometers per pixel. NASA Science 6. Thebe is not one of Jupiter's famous giant moons, but it plays an important role in the planet's faint ring system. Thebe sits near the outer edge of Jupiter's faint rings. Material can escape from its surface as dust, helping feed the ring system. That means a small moon can influence a structure that stretches through a much larger area of space. A tiny world can leave a giant fingerprint, and that idea appears again and again around Jupiter. Small moons may be tiny, but they can reveal huge events. A broken moon can create dust. A collision can create a family of objects. A captured asteroid can tell us about the early solar system. A moon's orbit can show where it came from. The deeper scientists look, the less Jupiter's moons seem like random rocks. They begin to look like a family history written in motion. Every orbit is a clue. Every collision is a possible chapter. Every newly discovered moon can add another line. But scientists are still facing a major problem. Finding small moons is one thing. Knowing how many are still missing is much harder. Imagine looking across a dark field at night with a flashlight. You can see large rocks easily. Smaller rocks become harder to see. Tiny pieces of gravel may disappear completely. Now imagine the field is moving, the flashlight is extremely far away, and the rocks are moving at different speeds. That is closer to the challenge astronomers face. Jupiter makes the problem worse because its system is so large. The farther a moon is from Jupiter, the larger the area astronomers may need to search. A tiny moon can also spend a long time in a part of its orbit where it is difficult to observe. Then it moves somewhere else. If scientists are not watching at the right moment, they may miss it. This is why the number 101 should not be treated as the final answer. It is the number of officially recognized moons, not a magical boundary where nature stops. The real number could be higher. Exactly how much higher is one of the questions future observations may answer. And there is something even more interesting. The smaller the moons become, the more numerous they may be. Large moons are easier to detect because they reflect more light. Small fragments are harder to see, but collisions can produce many of them. If Jupiter's outer moon families were created by ancient impacts, there may be a huge population of tiny pieces. That does not mean there are thousands of confirmed moons hidden from scientists. It means there may be many small objects that are difficult to detect and classify. Scientists must separate true moons from other bodies. They must track them over time. They must calculate their orbits. And they must make sure the same object is not accidentally counted twice. This is where astronomy becomes less like looking through a telescope and more like solving a giant detective case. The evidence is tiny, the distances are enormous, the objects move, and the answer may depend on observations taken years apart. Now think back to Galileo. He looked at Jupiter and saw 4 moons. He could not have imagined 101. He could not have imagined spacecraft flying past those moons. He could not have imagined cameras sensitive enough to find objects only a few kilometers across. And he certainly could not have imagined that 4 centuries later, astronomers would still be discovering new members of Jupiter's family. The discovery of the moons also changed something bigger than astronomy. Before Galileo, many people believed that everything in the heavens revolved around Earth. Jupiter's moons showed that this was not true. They provided a simple but powerful example. Not everything revolves around us. There were worlds with their own systems. Today, Jupiter is doing something similar again. Its moon system is showing us that even a planet we have studied for centuries can still hide surprises. The lesson is not only that there are more moons, the lesson is that our picture of a familiar world can remain incomplete. And the newest discoveries are especially exciting because we are now entering a period of much better observations. Telescopes on Earth are improving. Space telescopes can see faint objects in different kinds of light. Spacecraft near Jupiter can study the environment from close range. Every new tool gives scientists another way to search, but there is a limit. A telescope cannot simply point at Jupiter and instantly reveal every moon. Brightness, distance, angle, motion, and size all matter. The best search may require many observations spread across months or years. That means some missing moons could remain missing for a long time. A moon discovered years from now may have been sitting in Jupiter's system since the beginning of the solar system. The discovery date would be new. The moon itself would be ancient. That is one of the strangest ideas in astronomy. When we discover a moon, we are not watching it being born. We are finally seeing something that may have been there for billions of years. The discovery is new to us, not necessarily new to the universe. There is another mystery hidden inside these tiny worlds. Scientists want to know how Jupiter's moon system formed in the first place. The 4 giant Galilean moons are very different from the distant irregular moons. Their sizes, shapes, surfaces, and orbits tell different stories. This suggests that Jupiter's system may have been built through several processes, not one simple event. The large moons likely formed from material around young Jupiter. They were born close to the planet from a disk of gas and dust. The outer moons may have arrived later or formed through collisions and captures. Over billions of years, gravity reshaped their paths. Some objects collided, others were thrown away, some remained trapped. So Jupiter's moon system may be a record of chaos. Not chaos in the sense that everything is random. There are still rules. Gravity controls the motion. Orbits follow patterns, but over enormous amounts of time, small changes can create very different outcomes. A tiny collision can change an orbit. A close encounter can push one object farther away. 2 moons can pass close enough for gravity to alter their paths. A larger body can break into fragments. Those fragments can spread out and form a family. Scientists can study these patterns today and work backward. They can use computer models to ask what may have happened billions of years ago. If several moons share similar orbits, perhaps they came from one parent body. If their paths are very different, perhaps they arrived separately. The moon system becomes a kind of fossil record, and now the stakes become larger. Jupiter is not just interesting because it has many moons. It is important because its gravity has affected the entire solar system. The giant planet has been pulling on asteroids and comets for billions of years. Its huge mass has helped shape the paths of countless objects. That means understanding Jupiter can help scientists understand Earth's own history. Some objects that come into the inner solar system have their paths changed by the gravity of giant planets. Jupiter can send objects inward. It can also throw objects outward. Its gravity acts like a massive traffic controller in space. So when scientists study tiny moons around Jupiter, they are also studying the behavior of gravity on a huge scale. The moons are small. The lesson is not. There's also a human side to this mystery. For most of human history, Jupiter was just a bright point in the night sky. People could see it, but they could not see its moons. Then Galileo changed that. A simple telescope opened a door. Today we have instruments far more powerful than anything Galileo could imagine, yet we still face the same basic feeling he must have felt. We look at a bright planet and wonder what is hiding nearby. The difference is that our questions have become much bigger. How many moons are still unseen? How many are broken pieces of ancient worlds? How many were captured from elsewhere? How many are so small that current telescopes cannot find them? And could a future mission discover an entire new family of tiny satellites? These questions are not science fiction. Astronomers have already shown that new Jupiter moons can be found. The 4 additional moons confirmed in 2026 prove that the official count can change again. You. And the history of Jupiter discoveries shows that better observations repeatedly reveal objects that were previously unknown. There is one detail about those newly confirmed moons that deserves attention. Their names are not yet the kind of names most people remember. They are first identified using temporary scientific designations. That may sound boring, but it is actually useful. Scientists need a clear way to track an object before its identity and orbit are fully understood. A tiny moon might first appear as a moving point. Researchers record its position. More observations follow. The orbit becomes clearer. Then the object can be officially recognized. Only later can it receive a permanent name under the rules used for planetary satellites. This process protects science from a common mistake. Seeing something once does not prove you understand it. The object must be followed. Its path must make sense. Its movement must match the behavior expected from a moon. That careful process is why the official number is meaningful, but even with careful methods, there is still a hidden population. The smallest objects are the hardest. Some may be below the size that current surveys can reliably detect. Others may be dark enough to disappear against the sky. Some may be visible only under perfect conditions. That means Jupiter may still have surprises waiting, not necessarily a giant hidden moon, not a secret planet, probably something much smaller, a cold, dark fragment moving silently through space. And perhaps that is even more fascinating. A giant moon would be easy to get excited about. A tiny moon is harder to notice, but it may tell us more about Jupiter's history. A fragment could be evidence of a collision that happened billions of years ago. Its orbit could help scientists reconstruct an event that no human ever witnessed. So the smallest moons may carry some of the oldest stories. There is also a strange contrast between Jupiter's famous moons and its hidden ones. Europa gets attention because it may have conditions that could support life. Io gets attention because of its volcanoes. Ganymede gets attention because of its size and magnetic field. Callisto gets attention because of its ancient surface. But the tiny outer moons are important for a different reason. They help explain how the entire system came to exist. NASA is continuing to study Jupiter and its moons through missions such as Juno. Juno has already changed what scientists know about Jupiter's atmosphere, magnetic field, rings, and moons. Its close observations of smaller objects like Thebe show that even little worlds can become valuable targets when a spacecraft gets close enough. NASA Science 6. And Juno has also been studying the famous moons in surprising ways. In 2025, NASA reported that Juno had detected the final missing auroral signature from Jupiter's 4 largest moons. These moon-related marks appear in Jupiter's atmosphere because the moons interact with Jupiter's powerful magnetic environment. NASA Science 7. That discovery shows how a moon does not have to be physically touching a planet to affect it. Io, Europa, Ganymede, and Callisto all leave different signatures. Their influence travels through Jupiter's magnetic environment. In simple terms, each moon can leave a kind of fingerprint in the planet's glowing upper atmosphere. And now imagine combining that knowledge with the hidden moon problem. We know that moons can affect Jupiter. We know that tiny moons can feed its rings with dust. We know that moon families can reveal ancient collisions. We know that many outer moons are probably captured objects. And we know the official list can still grow. Put all of that together, and Jupiter starts to look less like a single planet and more like a giant system with its own history. Here's the question scientists cannot answer yet. Where is the lower limit? How small can a Jupiter moon be and still be found with current technology? And how many objects exist below that limit? A moon only a few hundred meters wide would be much harder to detect than a moon several kilometers across. If such tiny bodies exist in large numbers, our current moon count could represent only the visible part of a much larger population. But scientists need evidence before adding anything to the official list. That is why the mystery remains open. If another group of Jupiter moons is confirmed in the coming years, would you expect the number to stop near 101? Or could Jupiter eventually have far more confirmed moons? Tell us your guess in the comments, and if you enjoy mysteries that come from real science, consider subscribing. There's another reason the search matters. Jupiter's moons can help scientists understand how small bodies behave around giant planets. That knowledge can be useful when studying planets beyond our solar system. Astronomers are already searching for moons around planets orbiting other stars. These are called exomoons. Finding an exomoon is much harder than finding a Jupiter moon. An exomoon would be incredibly far away. Scientists would not usually see it as a separate point of light. Instead, they may look for tiny changes in how its planet moves or blocks the light from its star. The methods are difficult and the evidence must be carefully tested. Jupiter gives scientists a nearby laboratory. Its moon system lets them study many kinds of objects under conditions we can observe directly. If we learn how moon systems form around Jupiter, Saturn, Uranus, and Neptune, we may better understand what moon systems around distant planets could look like. That makes the missing moons more than a local mystery. They could be clues to how planetary systems work across the galaxy. And there is one more surprising thought. Jupiter is not finished changing our understanding of itself. The planet has been observed for centuries. Spacecraft have visited it. Telescope technology has improved dramatically. Yet new moons are still being confirmed. That means the solar system is not as completely mapped as it sometimes feels. We live in an age where spacecraft can land on asteroids and robotic machines can travel beyond Pluto. But even here, in our own planetary neighborhood, there are still things we have not seen. The unknown is not always billions of light years away. Sometimes it is orbiting the largest planet in our own solar system. This is why the story of Jupiter's missing moons feels so strange. The moons are ancient, the discoveries are modern, the objects have been moving through darkness for billions of years, waiting for a telescope sensitive enough to notice them, and when one is finally found, nothing dramatic happens in space. There is no explosion, no flash, no sudden birth. A computer compares images and finds a tiny moving point. Astronomers check the evidence. More observations are made. The orbit is calculated. Then humanity adds one more world to its map. That quiet moment is a discovery. It also reminds us how much our maps depend on technology. A map can look complete simply because the tools used to make it cannot see anything smaller. Improve the tools and the map changes. That is exactly what has happened with Jupiter. The planet itself has not suddenly gained 4 moons. Our knowledge gained 4 moons. That difference is important. Science is not about claiming that we already know everything. Science is about building the best picture we can, then changing that picture when new evidence arrives. Jupiter is giving us a perfect example. For centuries, 4 moons seemed enough to describe the most important part of Jupiter's satellite system. Then more appeared, 5, 10, dozens. And now 101 officially recognized moons. The number may grow again. Maybe the next discovery will be another tiny retrograde moon far from Jupiter. Maybe it will be part of a family created by an ancient collision. Maybe astronomers will find several objects moving together, or maybe years will pass without a major new discovery. That uncertainty is part of the excitement. We do not know what the next telescope will reveal. But there is a bigger lesson here. When we look at Jupiter, we often focus on the great red spot, the giant storm that has lasted for centuries. We think about the huge bands of clouds, we think about the 4 famous moons, but around all of that is a much larger, quieter world. Tiny objects are circling, fragments are drifting, dust is feeding faint rings, captured bodies are following strange paths, ancient collisions are still visible in the movement of small moons. Jupiter is carrying evidence from the early solar system all around itself. Some of that evidence is easy to see, some is hidden, and some may be so small that we have not found it yet. Imagine standing on Earth and looking toward Jupiter tonight. The planet is more than just a bright dot. Around it, dozens upon dozens of confirmed moons are moving. Many are too small to see without powerful equipment. Some are so distant that their existence was unknown until modern astronomy. And somewhere in that enormous system, there may be another tiny object that no human has ever identified. It could be moving right now, silent, cold, ancient, unnoticed. Maybe it has completed thousands of orbits around Jupiter. Maybe it was created when a larger moon broke apart billions of years ago. Maybe it came from another part of the solar system and was captured by Jupiter's gravity. We cannot know until we find it and study its path. That is what makes the missing moon such a powerful mystery. The answer is not hidden behind a locked door. It is hidden in plain sight inside the movement of light across a telescope image. And as our technology improves, that darkness becomes a little less dark. The next discovery could change the official number again. It could also change our understanding of how Jupiter's moons formed. One tiny object could connect several pieces of the story. A strange orbit could reveal an ancient collision. A new family could show that a much larger moon once existed. A new pattern could force scientists to rethink how Jupiter captured objects from space. And the smallest discoveries can sometimes create the biggest questions. So when you hear that Jupiter has 101 moons, remember that the number is not the end of the story. It is a checkpoint, a snapshot of what humanity has confirmed so far. Behind that number is a much larger system, much harder to see, and still being explored. 400 years after Galileo first watched those strange points of light move around Jupiter, we are still adding worlds to the list. The tools have changed, the cameras are better, the spacecraft are closer, the computers are faster, but the basic feeling is exactly the same. We look, we notice something strange, we ask what it is, then we look again. And sometimes we discover a moon that was there all along. If you want to follow that search as Jupiter's hidden population becomes clearer, subscribe and turn on notifications so you do not miss the next major discovery. Then leave a comment with your answer to one final question. Do you think Jupiter has only a few more undiscovered moons, or could hundreds of tiny objects still be hiding in its distant orbit? Share this story with someone who loves space, because the next strange world we discover may have been circling Jupiter long before humanity ever knew it existed. Thanks for watching, and keep looking up.